in the waves, we do have different concepts: transverse longitudinal waves, stationary waves, and general progressive waves. The stationary waves produced in the pipes, closed pipes, orgone pipes, so beads, Doppler effect. In that one, the questions which have been repeatedly occurring are from these three sections, please. So we'll be looking the some of the questions on these sections: general wave equations, that is longitudinal and transverse conditions, displacement and progressive waves, superposition of the waves in the Doppler effect conditions. So first one, if we go for the first question of us, a tuning fork is there of the frequencies some 800 hertz is there produced resonance. Resonance means the frequency of the tuning fork is matched with the frequency of the resonating air column over there. So with the upper end is open and the upper end open and the lower end is going to be closed. So it's a closed pipe. Fine. Successive resonances are observed at the 9.75, 31.25, and 52.75. So what is the speed of the sound? It's a resonance column apparatus. For the resonance column apparatus, velocity of the sound does not depend upon the L, that is the initial length or final length. It depends upon the difference between the lengths. So if you find that is different, it depends upon the delta L. So what is the delta L1 for the first case? If I go, it is 31.25 minus 9.75. So that comes out to be 21.50 centimeters. So let me check it out for the second case also, which is 52.75 minus 31.25. So 75.25, it should be the 50 over here. And 2 minus 1, this is going to be the 21.5 centimeters. So in the sense for both of them, the difference is going to be the same. Put it in the formula. 2 into frequency is how much? It is 800 into difference in the length is 21.50. Since it is in the centimeters, converting it into the meters. So just multiply them. This 10 power minus 2, these two zeros will go. It is 16 into 21.50. Suppose if it is 20 into 16 means 32, our answer should be just greater than 320, that is 344 should be our answer. So next case, please. A tuning fork is used to produce the resonance in a glass tube. The length of the air column in this tube can be adjusted by the variable piston. Same thing, resonance column apparatus is asking the same question on the resonance condition only. So he has given at the temperature 27 degrees, two successive resonance are been occurring at successive, that is 20 and 73. In the sense 20 represents for L1 if I take it, which is lambda by 4 distance, and 73 represents for your L2, which is 3 lambda by 4. Theoretically, L2 has to be equal to the 3 times of the L1, but practically we may get or we may not get. That's the secondary issue here. So in centimeters, he has provided to us. Now here the frequency of the tuning fork is 320. He is asking same formula. V is equal to 2F into this is L2 minus L1. That is 2 into 320 into L2 minus L1 value. 73 minus 20, that should be your 50 centimeters. 50 into 10 to the power of minus 2. These two zeros can be removed here. So 5 into 2, 10. 10 into 3, 32 is 320. 320 meter per second. So this should be nearby answer. It can be the 330 answer because the differences are going to be theoretically, they need to be satisfied over there. So next question, please. The two nearest harmonics of a closed tube. Tube is the one which is closed at one end and open at the other end. So it's a closed tube. Frequencies are, this is 220 and say of 260 fundamental frequency. Difference between any two successive frequencies is called as fundamental frequency. Fn minus Fn minus 1 is equal to fundamental fundamental frequency. So this is the condition, sir. So in the fundamental frequency means what is the difference between the 260 and the 220 will be the 40, please. That is equal to the 40 hertz. Next one, three sound waves of equal amplitudes, frequencies n1, n minus 1, n and n plus 1, they superimpose to give beats. The number of beats produced per second. You can find the delta n or the frequency between any two things, that is n minus of n minus 1. So if I go for these two things, it will be the one maximum cause will be between the alternate delta n is equal, since he has asked the produce beat number of beats per second. So first and last, if I take, it will be n plus 1 minus of n minus n plus 1 minus 1. This will be the 2 beats per second. Okay, na? So this is our situation, sir. Next one, the siren is emitting. Okay, siren is emitting. He has given the frequency. I'll be writing the frequency with the small f only. So frequency is this much. Away from the observer towards a cliff at the speed of 15. So the whatever is the sound is there, source of sound is moving towards this cliff with a 15 meter per second, and the frequency of the sound heard by the echo reflected from the cliff. Cliff is in the rest position, observer is in the rest position. Only thing that is moving is the source. Then your new frequency can be obtained as an f dash is equal to. Since the source is moving away from the observer, this is your observer velocity of the sound. Both of them are in the opposite direction, so you can relative velocity v by v plus vs into f. You can go for this one. So I'm putting down, substituting this particular thing. So this will be the velocity of the sound 330 by, this is 330 plus 15 with an initial frequency of 800. So this should come out to be somewhere around 330 by 345 into 800. So this value will be obviously less than 1. So your answer should be the less than 800. So it will be the most precise one. Next one, a rope of length L and the mass M hangs vertically. M1 hangs vertically from a rigid support. So rope length is going to be the L and mass of the rope is M1. A block of mass M2 is attached to this one here. Some extra mass M2 is attached to the free end of the rope. A transverse pulse of the wavelength M1 is attached to the free end of the rope. Transverse pulse of wavelength lambda 1 is produced at the lower end. So when it reaches to the, so when at this particular thing, that is lambda 1. So when it reaches to the top, it is lambda 2. So velocity of the sound is going to be is equal to root over tension by linear density mu. Tension can be written as an here mg by mu. On substituting at the point 1 and the point 2, v1 at the point 1, which can be written as an frequency into lambda 1 is equal to the root over only m2 by, I'm going for the ratio here. So due to that, I'm not writing this any further things. Lambda 2 is equal to, when it reaches to the second point, both the masses will be simultaneously acting, so it will be the m1 plus m2. So lambda, he is asking lambda 2 by lambda 1 will be equal to the root over, it will be the m1 plus m2 by, or combined root like this by m2. Fine. So like this, you can go for this lambda velocity is inversely directly proportional to the lambda conditions. The string is there stretched between the 2 points. which are separated by 75 centimeters. It is observed to have resonant frequencies. So that means at the 420 hertz he is getting the resonance, and 315 also is getting resonance. And no other resonant frequencies are in between the two. In the sense, it is also a resonance column apparatus. So that means, suppose if this is a tube, your first resonance is occurring at some point like this, or antinode like this, and this is your second resonance. It is the first resonance location. So at this particular instant, he is getting a frequency of the 420 hertz. That is, this distance is nothing but your 3 lambda by 4, and this distance will be equal to the lambda by, from here, total thing I'm taking. So one second. So total distance is going to be how much? That's the, so this entire thing from starting point to the, from here to here, this total length is 3 lambda by 4, and this is your lambda by 4. Generally, we take it as an L1 and this as an L2. That's why I have written the theoretical relation is L2 is equal to 3 times of L1. This is your resonance column apparatus. So there are between, there is no resonance occur means at this junction means that should be the difference between the two fundamental, two successive frequencies. So that means 420 minus 315 are successive should give you the fundamental frequency. Fundamental frequency. So what is the difference between these two things? Is 420 minus 315. This will be the 105 hertz. This should be your fundamental, sorry, this is your fundamental frequency thing, please. Great. Next one, question number 8. If we go for 4 grams of gas occupies 22.7 liters at NTP. Specific heat capacity of the gas at constant volume. That means at CV, he has given CV value is 5 joule per Kelvin per mole. He has given the speed of the sound also. What is the speed of the sound here? Speed of the sound is equal to root over gamma p by rho. The root over gamma p by rho can be replaced with gamma into, this is RT by molecular weight is equal to V, velocity. So from this one, we need to find out the gamma is equal to how much, so that if I can get gamma, so we can put it in the Cp by Cv is equal to gamma, and Cp is equal to gamma into Cv. So once we can get the gamma from here, we can get the other things also. So from here, gamma can be written as an velocity square into molecular weight by RT is equal to, velocity is how much? 952 whole square into molecular weight is 4 grams. He has given, convert them into the kgs, minus 3 here by R value, we take it as 8.3 into 273. You need to calculate this entire thing and substitute in the Cp is equal to gamma into Cv, then you can get the corresponding answer. Next one, please. Okay, a source of the sound ES emitting the waves of frequency 100 Hz and an observer O are located at some distance from each other. The source is moving with a speed of 19.4 meter per second. Okay, meter per second. Then the, what is the condition? At an angle of 60 degrees with the source observer line as shown in the figure. Since source is moving, the component of the source which is acting in the direction of the observer is going to be, this is Vs cos theta or cos 60, and velocity of the sound will also be in the same direction. So when we apply the Doppler effect in this one, f dash is equal to observer is in the rest position, source is moving towards the case. It will be V minus Vs cos 60 into your fundamental frequency. Velocity of the sound is 330 by, it is 330 minus, so how much it is? 19.4 into cos 60 1 by 2 into given frequency is 100 hertz. So this is the one, sir. Next, so what is the relation that we can write it down here? This, if I divide this one, this will come out to be somewhere around 9.2 or like this, 9.7, sorry, 9.7. So this will be the 330 by 320.3 into 100. So if I divide, what should be the value? The numerator is greater denominator. So value has to be greater than 1 only. So approximately when I go for this one, I think so we should be getting it as an around 1.03 we should be getting, and into 100 that will lead you to the 103 hertz. So you should be practicing and remembering these type of the small calculations which will be useful for you in Doppler condition space. The number of possible natural oscillations of the air column pipe closed at one end, and the length is 85 centimeters and the frequency below this. Since it's a closed pipe, what is the fundamental frequency formula? F will be V by 4L. So if F is equal to V by 4L, what is the fundamental frequency of this one is going to be? That is 340. Velocity of the sound he has asked. 4 into 85 centimeters, 85 into 10 to the power of minus 2. So 8 fives, 4 fives are 22. So okay, these two goes off, 10 power minus 2 will be left over, so frequency will be the 100 hertz. Since it is a closed pipe, the frequencies ratio will be what? Frequencies will be in the ratio 1 is to 3 is to 5 is to 7 is to 9 is to 11 is to 13 is to like that. But there is a limit, infinite number will be coming, but there is a limit up to below which how many we should be getting. So what is the value of the 11 into 100 is 1100. And after 1100, if it goes for the 13th one, so I think so it should be exceeding this one. So that is 1300. So this 1250 is less than the greater than the 1250 is greater than the 11th one and less than the 13th one. So that means we have to go for how many resonances are occurring or how many frequencies are occurring. 11 in the sense not this number. Now this is 1, 2, 3, 4, 5, 6th one. It is your fifth overtone, or that is 6 frequencies you can able to hear there. Next one, the length of the wire between the two ends of a sonometer are 100 centimeters. What should be the position of the two bridges below the wire so that the three segments of the wire, that means let this be your 100 centimeters wire fixed between the points, let it be the A and B. Two bridges are being placed, let it be the bridge B1 and let it be another bridge B2. So how many loops there will be forming? 3 loop formations. He is asking their locations of the bridges, first bridge and the second bridge, if this is being taken to be as an origin. If this is considered as an origin, where I am placing the B1 and where I am placing this bridge B2, so that it can be you can obtain in the case of frequencies, fundamental frequencies are in the ratio of 1 is to 3 is to 5 for all these cases. So length, frequency and the length are inversely proportional to each other. L1 is to L2 is to L3 should be equal to the 1 by F1 is to 1 by F2 is to 1 by F3. That means they should be in the 1:1:3 by 1/5. If I go for the LCEM, it will be the 15, or the ratio of the lengths will be 15:5:3. So in this particular ratio, they'll be divided. So if I want the L1, L1 is 15 parts out of total 23 parts into the maximum frequency. The thing is nothing but the total length is nothing but 100 centimeters. Okay, so he has asked in terms of this one only, so it should be the 1500 by 23 only. We need not to go for the further calculation. He has asked in that only terms. Second one ratio is 5 parts out of total 23 parts into 100. So that should be equal to the 500 by 23 centimeters. Okay. Next, two sources P and Q produce notes of frequency 660 Hz each. Both of them are producing the same frequency, that is, frequency of the P is equal to frequency of the Q is equal to 660 Hz. A listener moves from P to Q with the speed of 1 meter per second. If the speed of the sound is 330 meter per so velocity of the observer he has given it to be the 1 meter per second. Then the number of beats heard by the listener. Okay, so suppose try to imagine that P is here and Q is here. Now the person is been moving and the observer is been velocity of the observer is in this direction. These are both of them are producing the sound. Sources of sound are going to be zero. So in this direction, velocity of the sound will be there. Opposite to this one, in this direction, velocity of the sound will be there. So now since he is asking the number of beats, let me go for the first F1. That is the change in the frequency of the P is equal to where both of them are moving in the same direction by V into F, and frequency of the Q, let me take it as a QP only, is equal to velocity of V plus V naught by V into original F. So now the change in the frequency delta F is equal to frequency of the Q minus frequency of the P, which is equal to frequency of the Q. Take it as an what are the common things that we can take it out? F by V if I take it outside. Then the leftover is V plus V naught minus V plus V naught. So these two terms will goes off and your final formula will be the 2 V naught F by V. Now put down the values. 2 into velocity of the observer is 1, frequency is 660 by velocity of the sound is 330. Goes for 2 times, which is equal to the 4 beats per second. Okay. Next one. When a string is divided into as just I have written the same thing, formula in the earlier case, that is the length and the frequency relation here. The same value he is asking now. Same formula, this is going to be your relationship, please. Because the total length of them can be written as an L is equal to L1 plus L2 plus L3 like this. So if you replace them directly, you can get it. It's a formula question, please. So next one, two waves are represented by y is equal to a sine omega t plus kx. So y1 is equal to, if I write it, a sine of omega t plus kx plus 0.57. Now convert the second wave equation also in terms of the sine square. That is a sine of this will be omega t plus kx plus 1.57. Because cos to sine, I need to add the pi by 2. Pi by 2 means 3.14 by 2, which comes out to be the 1.57. This entire thing is of the phase 1. This entire thing is the phase of the second wave. So phase difference delta phi is equal to phi 2 minus phi 1. Greater value minus smaller value, you will be left with 1.57. That is 1.57 minus 0.57. That comes out to be the 1 only. That is 1 radian. Next one. A transverse wave is represented by the equation y is equal to a sine omega t minus kx for what values of the wavelength? The wave velocity, that is the velocity of the wave, is equal to the particle's maximum velocity. Wave velocity means frequency into lambda is equal to particle's velocity is a into omega, maximum value that too. So replace the omega here, f into lambda is equal to a into omega can be written as 2 pi f. So this will be the 2 pi f. Frequency on either side changes, then wavelength lambda is equal to a into it is 2 pi. So that comes out to be your option C. Next one, a wave in a string has an amplitude of 2 centimeters. The wave travels positive x direction of the x-axis with a speed of 128 meter per second. And it is noted that 5 complete waves fit in 4 meters of the length. What do you mean by 5 complete waves fit in that particular instance? So he is asking in the sense lambdas, values, and all these things. He is asking us to find out them. So total length is, so how many lambdas are there in total? 4 meters. In total 4 meters length. How many wavelengths are there? Suppose starting point is A and this is ending point B. So first wavelength, second wavelength, third wavelength, like this, fourth, and this one is the fifth, like this. So 5 wavelengths are there. So 5 into lambda is being distributed through a length of 4 meters. That means lambda is equal to 4 by 5, which is 0.8. From the lambda, you can determine k is equal to 2 pi by lambda. So what is the value of this 2 pi by lambda is? It is 2 pi into 0.8, which is 2 into 3.14 by 0.4. 0.8, if I remove here, it will be the 0.4. So somewhere around you should be getting as an 31 by 4. 31 by 4 means 7 point some 85 and 85 it will come out. Okay. Next one. Omega, we need to determine omega is equal to 2 pi f, or we don't know, since we don't know this one, we can also write in the omega velocity into k. So velocity into k like this also, or else 2 pi into what is the frequency there? Num 5 oscillations are the velocity it is having. Lambda value, k value also we have got it here. So anyway, you can substitute or you can find the frequency independently and also find this one. So in this case, velocity is there 128 and k value 7 point something is there. So let us replace those two things for the case for the situation. So it will be the 128 meter per second into 7.85. So 125 into 8 times is nearly 1000. So you should be getting a value near to the 1000. So it is 1005 radians. This is also radians. You can go for it. So equation of the wave. Amplitude he has given it as 2 centimeters. Convert it into the meters 0.02 meters. So it should be a 0.02. All of them are been same in the first line. Next. Let's verify the k value. This is going to be the k 7.5x. Okay, fine. Here the other two options are there, and omega is this one. So I can go for this particular thing equation. Why, sir? because it's stated that moving along the positive x-axis. If it is negative x-axis, then instead of the negative over here, it will be the plus sign. Next, at a point performs simple harmonic oscillation of time period t. And okay, it is performing the same SHM. The equation of the motion is being given by something like this: x is equal to a sine of omega t plus pi by 6. So after the lapse of the what fraction of the time period, the velocity of the point will be equal to the half of the maximum velocity. So that means we need to find out this particular t. So we have to, after t in terms of capital T, he is asking, so that what is the condition? Velocity should be equal to the half of its maximum velocity. Okay, so velocity of the particle v is equal to any particular instant is equal to omega into root over a square minus x square. And this velocity he has stated it half of the maximum. That means a omega by 2 omega goes off. On solving this one, x square is equal to 3 a square by 4. In that sense, x is equal to root 3 a by 2. Now when we substitute this x value here in the given equation, that is root 3 a by 2 is equal to a sine of omega t plus pi by 6. So a can be removed, and this is equal to the pi by 3 is equal to omega t plus pi by 6. So when we solve this one, we'll be getting what's there? Omega t value is equal to pi by 6. So now replace your omega here. I'm writing here. So t is equal to pi by 6 into 1 by omega. Omega can be written as an 2 pi by time period. 1 by 2 pi, and period will go pi cancel. This is t by 12. So this should be your answer. Next one. Two periodic waves I1 and I2 are passes through the region of the same time in the same direction. The sum of the maximum and minimum intensities. I1, I maximum can be written as an, what is the relation of the I maximum is I1 plus I2 plus 2 root I1 root I2 maximum, and I minimum is equal to same thing I1 plus I2 minus 2 root I1 root I2. So when I add these two things, what will happen? I maximum plus I minimum 2 times of I1 plus I2. Okay, so this will be your option 2. Next, sir. The wave described y is equal to 0.5 sine. This represents your amplitude. This is your kx term. This is your omega t. 7 seconds time. So then the wavelength and all these things he is asking meters and t in seconds. I suppose it should not be the okay. Then this will be okay. Fine. Then he is asking the lambda and the frequency. So since k is equal to 10 pi, and it can be related as an 2 pi by lambda, pi can be removed. Lambda is equal to 1 by 5 in the sense 0.2 meters. So 0.2 meters is in the first option, second option, as well as the option D. But this wave is traveling along the positive x direction. So since it is been moving along the positive x direction, we have to go for either the first and last options. Next, frequency omega is equal to 2 pi, which is equal to the 2 pi f. So frequency is equal to 1 hertz. So according to the given situation, this is the better option for the case. Next, two tuning forks of wave. Tuning forks y1 is equal to this much. Y2 he has given number of beats produced. From the first equation, omega 1 is equal to 2 pi f1 is equal to 500. From this one, frequency is equal to 250 hertz. And second case, omega 2 is equal to 506 pi. Okay, here also pi. So from here, you can write it as n. This should be equated to the 2 pi f2. On solving, you should be getting how much? 253 hertz. Now, difference in the frequencies is the beats, which is f2 minus f1, which comes out to be the 253 minus 250, which is 3 hertz. This is a relationship. Next one, the transverse wave propagation along the x-axis is represented by y of x comma t 8 sine. This is kx minus omega t minus pi by 4. So wave is traveling along the positive x direction. The speed of the wave, velocity of the wave is equal to omega by k. From the given relation, omega is 4 pi by k value is 0.5 pi. Pi goes up 0.5, 1 by 2 can be written as it should be the 8 meter per second. This is our option. A point source emits sound equally in all directions in a non-absorbing medium. 2 points P and Q are 2 meters and 3 meters apart from the source. The ratio of the intensities of the waves at those points. We know that intensities of the waves I2 is going to be R2 square by R1 square. That is, intensity is equal to power by area, or it can be written as an power by 4 pi R square. So now put down the values here. So it should be the 9:4. Direct relationship. Next one, the phase difference between the two waves. Same model equation as we have done. Convert the cos into the sine. So first equation can be written as an y1 is equal to 10 to the power of minus 6 sine of 100t, that is omega t, plus x by 50, that means k value is given, plus 0.5 is its initial phase. Okay. Next, y2 I'm directly writing now in terms of the sine. This is sine term of, so how much I should write here? Same thing, 100t plus x by 50, both of them are same. Sine of 90 plus theta is cos theta. This is going to the plus 90. 90 means 3.14 by 2, that is 1.57. Now subtract these two things, phase difference, delta phi will be, all the other values will be cancelled. Left over is 1.57 minus 0.5. So that will be the 1.07 radians. Next, a car is moving towards a high cliff. The driver sounds a horn of frequency F. The reflected sound heard by the driver has a frequency of 2f. If nu is the velocity of the sound, then velocity of the car in the same units he is asking. Okay, fine. So car is moving towards the cliff. Driver sounds a frequency f. So that means reflected sound. So reflected means for the car which is moving towards the cliff, f1 can be written as an, since observer is in the rest position, v minus vs into f. So it is reflected and coming back. That means f2 should be equal to how much? Since it is under the reflection, it should be the v plus v naught by v into f1, which is written as an v plus v naught by v into f1 can be written as an v by v minus vs into f. So these two things goes up. By the way, here source velocity and your observer, both of them are the same since observer is sitting in the car. So the same formula, the f2 value, how much he has given, it is 2f. 2f is equal to v plus v naught by v minus vs. but both of them are the same. This is F, remove this one. Now I'm expanding this. This is 2V minus 2Vs is equal to V plus V naught. Cross multiplying this one. Let me replace the V not in terms of the Vs. Then it will be the 2V minus 2Vs is equal to V plus Vs. So it will be the V is equal to how much it will be the 2 and this is 3Vs. So velocity of the source which is equal to the velocity of the observer which is equal to the V by 3. So this is our option. Next one, an observer moves towards a stationary source with a speed of 1 by 5. That means velocity of the observer is equal to velocity of the sound by 5 times. The wavelength and the frequencies are of the apparent frequency and the wavelength recorded by the observer is how much. So observer is moving towards the stationary source. Observer is here, source is here, stationary source. So since he is moving in this direction with the velocity of the V naught, sound direction in this direction, both of them are in the opposite direction. F dash is equal to V plus V naught by V into F. Substitute the V naught value, that is V plus V by 5 by V into F, and that should be 6 by 5 in the sense 1.2 times of the F. So 1.2 times of the F here we have got, and next he is asking the lambda is. So obviously you can get the lambda in the either same thing. So or else reverse these two things. F dash can be written as an C by lambda dash is equal to V plus V naught by V into C by lambda. C can be removed and solve the same sum. So that should be the 1 by lambda dash is equal to V plus this is 6 by 5 times of 1 by lambda. Or this is 1.2 or anything like that. Okay, so you should be the 1 by 1.2 that you'll be getting. Lambda dash is equal to 5 by 6 times of lambda. What is the 5 by 6? C is going to be around 0.8 something. It should be there. So I think so. Here the option also should be 0.8 or 0.5, 0.6. Okay, no problem. So this should be the better conditions. Fine, sir.